Today we are talking about chapter 4.3, which is all about multiplication with decimals and whole numbers. Wait a minute, isn't that what we did yesterday? Multiplication with decimals and whole numbers? Daniel?
We did, but we used base 10 blocks.
We did, but we used a different strategy. Yesterday's goal was using a model, drawing a quick picture to model the multiplication of whole numbers and decimals. If you look at our learning goal today, we're still multiplying a decimal and a whole number, but we're using different strategies today. We're using properties, what we know about properties, and what we know about place value. Okay, so let's think really quickly. What properties do we know about? What are some mathematical properties we know? Liam?
Commutative property of addition or multiplication.
Commutative property of addition or multiplication. Let's think about this for a second. If we're talking about multiplication, are we talking about the multiplication properties or the addition properties? Multiplication, probably. So there is the commutative property of multiplication. Yarden, what other properties do we know about? Identity property of multiplication. There's one more property I have in mind that we talked about earlier this year. Tanvi? Distributive property. Okay, remember that's when we distribute the pieces to all the different parts equally, okay, before multiplying. What do we know about place value? What are some things we know about place value that might help us when we multiply? Clarissa?
Well, we know that about the tenths and hundredths and stuff.
What do we know about the tenths and hundredths? How do tenths relate to hundredths?
They are like 10 times and 1/10 of each other.
Yeah, so 10 hundredths equals 1/10. And 10 tenths equals 1. 10 tenths equals 1. And 10 ones equals 1. And 10 tens equals 1. We know that that's the relationship, right? As you move along the place values chart, it gets 10 times bigger when you move to the left, and 10 times smaller when you move towards the yeah, okay, so we're ready to go. We know about properties and we know about place value. So let's see how that relates to multiplication. It says, in 2010, the United States Mint released a newly designed Lincoln penny. Do you guys remember this happening at all? No. There was a new penny that was released in 2010, okay? A Lincoln penny has a mass of 2 5/10 grams, 2.5 grams. So each little penny weighs 2.5 grams. If there are 5 Lincoln pennies on a tray, what is the total mass of the pennies? So let's think about this in steps. It says the first question we have to think about in our head, this is all the stuff that we're thinking in our head. How much mass does one penny have? How much does each penny weigh? Yanming? Yeah, 2.5 grams. How did you know that the mass of one penny is 2.5 grams?
Because it says a Lincoln penny has a mass of 2.5 grams.
Okay, the problem gives us the information. Each penny weighs 2.5 grams. The next thing we have to think in our head is, how many pennies are on the tray? How many pennies are on the tray? Rashika? Because the problem tells us there are 5 Lincoln pennies on the tray. So, try to use grouping language to describe what we need to find. We need to find how many groups of what? We need to find blank groups of blank. Adam?
I think you've,
How many groups of something are we asked to find?
5
5 groups.
of 2.5.
Yeah, we're being asked to find 5 groups of 2.5. How would I write this into a math sentence? 5 groups of 2.5. Let's change it from words to numbers. Sarah?
5 multiplied by 2.5.
Yeah, 5 times 2.5 will help us find the answer of what is the total mass of the pennies on the tray. Now, the first step to solving a math problem is always to estimate, okay? Why is it important to estimate? We've talked about this every single time, but let's talk about it one more time. Why is it important to estimate? Daniel?
Because if you estimate and then you find the exact answer and the exact answer is in the zone of the estimate, you know it's correct.
Yeah, it helps you because you know what the zone should be of your answer. So, I don't know about you, but it's hard for me to round decimals in my head. Remember, when we're estimating, it's all about doing things in our head. So, the best way to round to estimate is to round the factors to the nearest whole number. So, it's 5 is one of the factors. Is that already a whole number? Okay. 2.5, is that a whole number? Let's round that to the nearest whole number. What's 2.5 rounded to the nearest whole number? When we round to the nearest whole number, which place value are we rounding to, Thomas? We're rounding to the ones. So what's 2.5 rounded to the nearest ones place? Neha?
3.
3. 5 times 3, can we do that in our head? 15. So we know that our real answer needs to be around the zone of 15. Okay? Now that we've done that, we're ready to actually multiply. So one way to multiply 5 groups of 2.5 is to use the distributive property. We can take the factor 5 and put it on the outside. Okay? This stays on the outside right here. Then we can break the second factor, 2.5, into 2 parts. What plus 0.5 will equal 2.5? What goes in the blank there? Matthew? So 0 plus 2.5 does equal 2.5, but you'll notice here we have 0.5 over here. So what needs to fill in this blank? What in the parentheses plus 0.5 will equal 2.5? Okay. Is it important for you to pay attention and listen? Okay. We've now broken up the 2.5 into 2 parts, 2 and 0.5. Does 2 plus 0.5 equal 2.5? Yes? Okay, very good. Now we're ready to distribute the factor of the 5 to each part. We have to do 5 times 2 and 5 times 0.5, right? So 5 times 2 plus 5 times 0.5. Now let's multiply. What's 5 times 2? 10. What's 5 times 5 tenths? How can we do that? What strategies do we have that could help us multiply 5 times 5 tenths? What could we do? Arushi? You can use a quick picture. Let's try that. How many groups of 5 tenths do I need to draw? Ah, yes, I see your 5 hands. So here's 5 tenths, 3, 4, 5. And I need 5 groups of that. 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Do I have 5 groups of 5 tenths? Okay. Do I need to regroup? I can trade these 10 tenths in for a flat. I can trade these 10 tenths in for another flat. Can I do any more regrouping? No. So let's look at what we have. How many ones do we have? 2. And how many tenths do we have? 5. So 5 times 5 tenths is 2 and 5 tenths. Now we're ready to add. 10 plus 2 and 5 tenths is?
12 and 5 tenths.
12 and 5 tenths. So therefore, 5 times 2.5 is 12.5, or 12 and 5 tenths. Very good. Let's check to see if our answer is in the zone of our estimate. What was our estimate when we used the whole numbers? 15. Is 12.5 pretty close to 15? Yeah, so does that give us some confidence that our answer is probably correct? Yeah. Is we can show partial products. We can do part of the product at a time, okay? So the first step would be to multiply the tenths. This is kind of like when we multiply whole numbers, right? We do the different place values at a time, right? Okay, so first we multiply the tenths. 5 times 5 tenths is how many tenths? 5 times 5 is what? 25. So if I have 5 groups of 20, or 5 groups of 5 tenths, how many tenths do I have? 25 tenths, right? And we know that 25 tenths is the same thing as 2 ones and 5 tenths, right? So let's go ahead and write that. That's 2 ones and 5 tenths, right? Then we multiply the ones. First we multiplied the tenths place, and now we're ready to multiply the ones place. What's 5 times 2? 10. And then we add the partial products together. 10 plus 2.5 is 12 and 5 tenths. Okay? Do you guys see how this is similar to using the distributive property? How is this similar to using the distributive property? Arushi?
You're still multiplying each factor
Yeah.
in parts. You're not multiplying them together.
Yeah, you're just like how in the distributed property, I'm going to go back a slide really quickly. Having a thickness of 1 35/100ths of a millimeter, 1.35 millimeters, the dime is the thinnest coin produced by the United States Mint. If you stacked 8 dimes, what would be the total thickness of the stack? Okay, so imagine you're putting 8 dimes together, and you know that each dime is 1.35 millimeters tall. You're finding out what is the total thickness of your stack. How many groups of what? Blank, we're trying to find blank groups of blank. What are we trying to find? What are we trying to find? Yarden?
8 groups of 135.
Yeah, 8 groups of 100, or 1 and 35/100ths. 135/100ths is also correct, right? 8 groups of 1.35. Very good. So in a math sentence, that's 8 times 1.35. Go ahead and take good notes on this. Now, step 1, you can also multiply this by changing everything into whole numbers. What would I need to multiply 1.35 by to make it into whole numbers, to get rid of the decimal point, or to move the decimal point all the way to after the last digit? How many places over do I have to move the decimal point to make it a whole number? 1, 2. If I need to move it 2 places to the right, I'm multiplying it by 100, right? So you can think in your head that 1.35 times 100 is 135. Then what you can do is you can multiply it as if you were using whole numbers. 135 times 8, and then you'll multiply it, right? We know how to do that multiplication. But then is that our real answer? Because in the beginning we multiplied by how much? 100. To find our real answer, we're going to have to divide by what? 100. And dividing by 100 is the same thing as multiplying by 100, because when you multiply by 100th, you're moving the decimal point 2 spots over to the left, right? So because we moved the decimal point 2 spots over in the right, over here, in the beginning, when we have our answer, we're going to need to move it 2 spots over to the left to get to our final answer, right? So our final answer should be 10 and 8 tenths of a millimeter. Does that make sense? So because we moved the decimal point in the beginning here, to make it so we have whole numbers, after we find our big whole number answer, that's too big, right? It's 100 times too big. So we're going to have to multiply it by 100th to move the decimal points back over to where it started from.